And then I'll just talk about the bottom part here as well, okay? So the domain and range for this one, if it's set notation, we go from 0, so you might want to write this down, all the way to 2.35. So it'll be 0, 2.35. Okay, and this one, for the range, we go as low as 0.18 and as high as, you got to watch out for the numbers, right? When they're closed, you get as high as 3.45. So it doesn't, sometimes the y-intercept helps us to figure out the domain and range, sometimes it doesn't, okay? This is 0.18, 3.45. There we go. And then here, for domain, I'm going to use d for distance, so we go from 0 all the way to 100. So that'd be 0 to 100 like that. For range, we're going from negative 37.85, and I'm going to use h for my variable here along the y-axis, all the way to the highest of 37. So you have to pick between 30 and 37. They are close, but 37 is the highest value along the y-axis. So that would be, is that going to fit in? Let's see. There you have it. Okay. So you have your domain and range examples. Okay, you can't say you don't have enough. Let's talk about the bottom piece here. If you're still writing this down, let's talk about this. This is important to understand, because if you don't know this, it might throw you off. Okay. This is just an aside. Okay. If you have the quadratic equation in general form, like this, but you notice that b is missing, so the x term is missing, okay guys? This is gone. So if b is equal to 0, okay, if b is equal to 0, there is no x term, okay? Then it will look like this. And what is so special about it? Right, it ends up being ax squared plus c, right? That's all. Then this y-intercept, the y-intercept is going to be the same as the vertex. In fact, your y-intercept is also the vertex, and the vertex is the y-intercept. That's one thing that I want you to understand. It is, in other words, the y-axis splits this thing in half. Would that make sense to you if I said that? The y-axis splits this thing in half, because this is your vertex. So I just thought of it now. I will just add it to your notes here. The y-axis splits it in half. So therefore, that is technically the axis of symmetry. The y-axis is itself the axis of symmetry. So just think about that, because sometimes students are like, find the y-intercept. They try to use the calculator to find the y-intercept. Find the vertex. They find the vertex, they're like, wait a minute, they're the same. Not a big deal, it's just a fact. And that will be the case when you have no x term, okay? On the other hand, if b is not equal to 0, okay, so then the vertex is different than the y-intercept. So you have your y-intercept here, and your vertex is going to be somewhere off to the side. It comes over here. Okay. Just an observation. That's all. If you honestly, if you don't remember this and you just use your calculator, as long as you don't panic when they are the same, you're technically okay. Right? On the back side of this, I'll add one more thing about it, about the parabola. just items of interest that help you have a bigger picture as you're going to tackle different problems, okay? So let's go to the back side of this. It's blank. It is blank for a reason, and it's for me to talk about on 35. Make sure you write this down. Effects of A, B, and C on the parabola. So if you have this, right, that's the general form. What does A tell us? It gives us, right, direction of opening. And width. How do we know which way it's opening? Whether it's positive or negative, right? Width, is it less than 1 or between 0 and 1? Is it bigger than 1? That's narrow, okay? But, so that's A. Okay, I'm going to do B right next to it. B does a horizontal shift. Right? So B is horizontal. So if you want to, this is what I'm going to do to help you out. Give you a visual. As you change B either to the positive or to the negative, this is what happens. If B is turned, if B is changed to a negative, the parabola would shift to the right. If you change B to the positive end, it will actually end up shifted to the other side. Okay? If B is equal to 0, B is going to be right in the center. The axis is going to cut it in half. So it shifts it this way, but slightly, it's not perfectly side to side. It kind of shifts it a little bit down and up, down and up. It's almost like a swing. It's almost like a swing. Okay? That's what B does. And I don't have my Desmos queued up. If I had it queued up, I was gonna show you that. I will yet. I think it's important. So this is what A does. This is what B does. And then last but not least, I'm gonna cut this here. I'm gonna say that C does a vertical shift. C is responsible for a vertical shift here. So if you think of a graph, any graph, okay, if C is 0, it would be right there. But if C is positive, it would actually raise the whole thing. So this would be C positive. And if you drop it or decrease the C value, it would actually drop the whole parabola downwards. Okay? So if you want to have a continuum here, as you shift it up positive, it would go above the x-axis and just keep going up. Similarly, if you go decrease it and go to the negatives, it will go below the x-axis. Okay? So that's what the C value does. Okay? I will make a little note here. Decreasing C will shift the entire curve downwards. And vice versa. Okay? So if you increase it, it will move everything up. And so that's just that. Let's see if it doesn't take me too long. I had it ready to go the other day, but sometimes I run out of battery. Oh yeah, I have it ready. Look at that, look at that. So let me just block your view a little bit. So this is just a parabola here that you see. And I will make, I will change the value of C. I'll just loop it back and forth. So watch this. If I press play, see how the whole curve, as you increase the value of C, so look on the left side here. I'm decreasing it and I'm increasing it all the way to 10. And then it drops back down. So the whole curve is going to be raised or lowered if you change the value of C of that quadratic equation. Okay, that's something I want you to understand. So let's stop it there. What if you change the value of A, right? So A, if I kept looping, it'll make it narrow, 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 gets wider, wider, and then it actually ends up pointing down, right? So it does like a back and forth as you change the value of A. So it changes the width, but it also changes which way you're pointing. Okay, so if whether or not you're pointing up or down, and that's determined by it being negative or positive. Okay, so I need you to understand that. That's pretty good for you to know. Pause it. And then B is the horizontal shift. So if you were to change the B value, see how it changes it? It's almost like a swing. It's not like a perfect side to side, but yes, to a certain degree, it does that, right? And when B is equal to 0, let me see if I can stop it at 0. Probably not. Remember, when B is equal to 0, it'll be right down the center, like the y-axis will cut it in half. It's almost 0, but you can see that. So if you change it to negative, it'll shift to the right. If you change B to a positive value, the whole thing will shift to the left. And we could do the same thing if this is pointing down like that. Okay, if you change B, am I blocking your view there probably? Right, it does the same thing. It shifts it back and forth. So that's the value of B. But the most important one of all, I think, is C. Understanding that C changes the height of the whole thing. It basically shifts it either up or down. And A, right, makes it narrow or wide. And then it will also change the direction of the opening if it's positive, right? So keep that in mind, okay? Let's continue. I don't want you to just blindly type these in and not understand what's happening, okay? So, what are we time-wise? Okay, I'm going to continue with the word problem. Okay, so we're going to go to 36 here. I completely missed the fact that the bell was about to go when I started it. I wouldn't have started it if so let's pretend like 36. Let's pretend like nothing ever happened. Okay, I'm starting from scratch. Okay, have your calculators ready because I need you to type this in. So we had a quadratic equation that would model the path of a baseball that has been hit, right? So this is modeling it. So we realized, right, that the variable on the right-hand side is our x variable, so that's time, and height is whatever is on the left side here. So we know now that this is the case. The first thing that we were asked is, what's the initial height of this? And the initial height is given to us by the y-intercept, which we could easily just get straight from this general form. It's 0, 4. Just listen carefully. This is not the answer. If you just give me that, that's not the answer. The answer is, you can state this, but then you have to actually say that the 4 is the answer. 4 feet at 0. At time 0, at the very beginning, you're 4 feet above the ground. Let's put that down. Above, make sure you copy above ground. How do we know we're above ground? It's positive. Okay, answer is positive. So keep this in mind down the road. If you get a negative, I'll ask you, what does this mean? It means that you're below ground, you're below the water surface. Within the context, just read carefully. Okay? It won't always be positive, I guarantee you that. B, determine the maximum height of the ball. We found it at the vertex. We know what that is going to happen at the vertex, so we went second trace max. Can you just do that real quick? I have it still from yesterday, second trace. We have to pick maximum. Most questions are going to be max, folks, when it comes to word problems. And I found it to be 357, 66.5, right? That's what I got on my calculator. That's not the answer. You're close, okay? So maximum height is 66.5, and there is always a unit. We are in feet. So just make sure you put feet down. So it's going to come down to the little things that are going to cost you marks if you don't put them down, right? So I really want you to show me how you found the vertex, but then you tell me that the 66.5 is actually the answer. Because if you just give me this, you're close, but we don't know if you know which one of these two numbers answers the question, okay? C, how long will it take for the ball to hit the ground? Before I answer C, can I just say something here? Maximum height is 66.5 feet. I'll just say this, after 3.5 seconds, okay? It's 3.5 seconds after being hit that you achieve the maximum height of 66.5 feet, right? And so I want you to understand that. C, how long does it take for the ball to hit the ground? When do you hit the ground? Let's do our graph here. We don't start right on the ground, correct? We're at a height of what? At time 0, we're at 0.4, somewhere here. This is just a sketch, this is not a graph, okay? Then the ball gets hit, and then boom, you hit the ground here. The ball hits the ground. You don't hit the ground, hopefully, okay? So this is just to picture what's happening. So that is where you hit the ground. That's called my x-intercept, correct? That's the x-intercept. So we find that going y2 is equal to 0. We're going to go second trace, intersect. So let's go ahead and find it together. Okay. y2 is equal to 0, hit graph, second trace 5. I'm going to go to the one that's on the right side. Oops, you can see that. Enter, enter, enter. And that is 7.260. Okay. Still not the answer though. It remains in the air for 7.26 seconds. Okay, just a little statement. I don't need you to write me an essay, right? Or a paragraph. It's just like a short little, this is what it is, okay? Tell us you understand what's happening, okay? What's D asking for? I'm going to slow down a little bit because you're writing this down. I need you to hear what I'm saying as well. D is asking, calculate the height of the ball 1.5 seconds after being hit. Do you want me to translate that for you? This is what the question is asking, and a lot of questions ask this. When time is 1.5, what's the height going to be? That's really what the question is asking. Which function on my calculator can I use to make this happen?
Trace value.
Value. Second trace value. Yes. So I'm going to go second trace value, and I'm going to let x equal to 1.5. I don't know if you recall, but we could use this to find the y-intercept as well, correct? Second trace value, x is equal to 0. And let's go ahead and see what y is. So I'm going to press those buttons. Second trace value, 1.5. And there it is. It's blinking on my curve. It's 45.48 if you round it to 2 decimals. You know what? This, if you put units next to that and just have the one number, you circle it, you're actually good. Because that is the number. You're not giving me a point, right? You're just giving me the height. And you put units behind it, and you're good to go. That's how high you are after 1.5 seconds of being hit. The ball, not you, but anyways. E, determine the time remains at or above 49 feet. This one is tricky. Do we have room on the back side here? Oh yes. I inserted that just last after, because I need to graph it, and I was like, where am I going to fit the graph? But I put a grid on the back side, so we're good. E is tricky, okay? Please, this one I'm going to actually give you a sketch one more time, okay? Sketching it makes it easier to wrap your head around. Just making sure we don't start on the ground, correct? How do we know we're not starting on the ground? Because when time is 0, my height is 4. So make sure you don't put the point right there. And then I don't care from there on, and you just go like this. Okay? So we want to know how much time was spent at 49 feet or above. So this is what the question wants to know. We're going to draw a line called y is equal to 49. We're going to graph that. Let's go ahead and do that on our calculator. So we're going to go y2, change y2 to 49 in this case, not 0. We don't want, and then hit graph. And you see it there, right? That is my reference. That is the 49. So I want to know how much time was spent above that. Okay? So this is how we're going to do that. We're going to figure out this first intersection and write it down. Okay? Then we're going to find the second intersection, only the time. We only care about the time here. We're going to figure out the 2 times here. Then we're going to do what with those 2? Subtract them. Because if you take away this time from the first time you hit 49, then you get the difference in time, the time that was spent above here. Okay, so let's go ahead and do that. How would we do that? Second trace intersect. Yes. So we're going to find the intersection the first time the ball gets to 49 feet. But watch this. How many decimals do you think I'll write down? We're not done yet, right? So I'm going to write down 4 decimals. Because that's not the answer yet. We want to get to it. Okay? But this one you can't just copy paste. That's the downside of using second trace. I'm going to find the intersection one more time. This time I'm going to go closer to the second. So enter, enter, enter. And there I get 5.4613 if I round. 5.4613. And now we're going to do the calculation. Okay. Can I just ask you to, when you want to show your work, you don't have to show me this. I don't need this. I just need you to do this. y2 is equal to 49. And then you went second, trace, intersect. You found the first time, which is this, the second time, which is this. And I don't know if you've ever, maybe if you took physics or science, delta means subtract. So You want to know the time in between these two. Delta just means subtract. So we're going to go 5.4613 minus 1.6816. This question would most definitely be worth 2 marks, folks, a question like this. Because notice that it says, how long was it at or above? It's not just one time. It happens twice, right? It happens once on the way up and then again on the way down. So this is implying we want to know the time that's spent between. So if you do this, you get 3.78 seconds. Okay. At or above 49 feet. This is your final answer here. I'm going to use a highlighter here. This time is what was spent here. What was the total flying time of this thing? We already found that above. Anybody? How much time did this whole thing take for it to hit the ground? From the time it's hit to hit the ground. And I would argue 7.26 seconds. Out of those 7.26 seconds, right, 3.78 were spent at 49 or above. Okay? Could you figure out how much time was below, knowing these two pieces? Just take this one away from the total time. Right? If you subtracted these two now, you would actually find the time spent below 49. And I will do that just because it's convenient. It doesn't ask for it. I'm going to just cut this here. If you have space, please add this. Time below 49 feet. Add it in the corner somewhere where you have some room. I'll go total minus delta t. That's what I'm going to say. So 7.26 minus 3.78. And that would be 3.48 seconds. So almost half. It's about half. Almost, not quite. I'm going to add a highlighter to this. Time below, right? It's talking about the time spent here on its way up, and then again back here on its way down. So if I asked you for time below, the best thing to do is find the time above, subtract it from the total, and then you get the rest. I know this one right now, don't worry about it too much if it's causing you some headaches, right? If you understood the orange part when we got here, you're doing pretty good. This is a little later. All right, now the best part, the graphing part, which I already practiced with you, but it's a little different because we're not including all 4 quadrants here, only quadrant 1. So let's go to 37. I will transfer over important information here. Before I graph, I will copy down my vertex. What was it again? It's 3.57, 66.5. This is on 37. X-intercept. How many x-intercepts? Normally this would have 2, correct? But I don't care about the negative x-intercept. Right? Just to give you a heads up, action starts here. Technically, this on your calculator, you would have this x-intercept here, the negative one, but we don't care about it because action starts here. So in this case, the only x-intercept that I want is here when the ball lands on the ground. So don't be using negatives. Okay? This would be, I already figured it out, 7.260. So vertex, x-intercept, and my y-intercept. Those are must. Those are a must to make a good graph. I wonder if I should add that to your notes later. Don't use the negative, but that's okay. For now, we'll just stick with this. Before you even start, please do this. We know this is time in seconds. The question gave that to you right away. And put an arrowhead here at the bottom. Then go to the top, call this height, and that is in feet. You got that out of the way. I haven't done this before, but I will do it. Why don't we label this with the equation already as well? Do this at the very top here. H of t is negative 4.9 t squared plus 35t plus 4. That way you will not forget. I don't need a label other than that. I don't need a title. I know some teachers might have asked you to put a title. We don't need that in this. Okay. And I gave you a grid already, so use it to come up with a good scale. I'm going to look at my x-intercept. I need to make sure 7.26 fits in here. So if I go 2, 4, 6, 8, that'll work pretty good. So I'm going to go 2, 4, 6, 8, 10. Consistency is all I care about. If you go up by 3s or by 4s or by 5s or by 10s, I don't really care. Just don't go up by too big of a number and then your graph is like a little tiny curve. I would like it to be visible, like a nice, try to fit it to the grid. My vertex is 66.5. That's the y value. So I'm going to go 10, 20, 30, 40, 50, 60. That's going to be tight if I go by 10. So what am I going to go up by? What did I do on my key here? I went up by 15s. So 15, 30, 45, 60, 75. So now I have my scale. I'm going to plot my numbers. Okay? 0, 4. This is 7.5 right here. This would be, right? So 0, 4 will be somewhere in there. 3.57, this is 3 right here. So 3.57 is going to be just over here, and then I go to the top and I find 66.5. That would be, this would be 15, so 67.5 is right there, so 66.5 is right about there. I'm not kidding you, close enough is good enough. Okay? Then it's 7.26. This is 7. 7.26 is right there. Now you have everything you need. I go to my vertex. I go out and down like this. Back to the vertex, out and down. And there you have it. Full marks if you did what I just did here. And most of the time you will have all your information already gathered. So that's that. What else is it asking us for? State the domain and range of this scenario. Assume the ball stops upon hitting the ground. Okay, so we're going to do that. What is that? What letter is that? G. Domain. For domain, I would go from 0 to 7.26. And for range, it would go, does it go from 0? Yes, it does, right? All the way to the highest point, which is 66.5. Oh, sorry. Wrong format. My bad. This would be H, right? Or H of t, it doesn't matter. All the way to 66.5. And I'm not using interval because I know you're pretty good at interval. So I'm going to just stick with set notation here. We're almost done, okay? Just hang in there. H. Pay attention to H. I'm throwing a curveball to you already. I'm trying to cover as much as possible here. Let's read H1. I'm going to flip back. What does H tell us here? State the domain and range of this scenario. What does it say here? I'm going to highlight that part. The first one that we just did hits the ground. But what if we assume that the ball was caught at 6 feet above ground? So a person catches it and it stops right there in the glove. How would the domain and range change in that case? Let's go to the back side here and let's try to visualize this. Here it is. Let's just sketch it, okay? It gets hit here and then it gets caught at after some sort of time, it gets caught at 6 feet, correct, above the ground. This is 0, 4. This is 3.57, 66.5, right? So these 2 points are already known to us, the vertex and the y-intercept. But I need to know this. How would I find out this question mark here? How could I find that point? What intersect, right? Let y2, we're going to let y2 equal to 6. Second, trace, intersect. Let's go ahead and do that. y2 is equal to 6. Hit graph. And there it is. This is the one I'm interested in at the bottom here. Not this one, but this one, right? It gets caught right there. Second trace 5. Enter, enter, enter. And that's 7.09. Okay, so how does this change my domain and range? I know that my domain goes from 0, right? It keeps going, keeps going, keeps going. It gets caught right there at 7.09. So that's how that changes. Okay. And my range, how's that going to change? What's the lowest height I ever achieve? 4, right? It never hits the ground. And the highest is 66.5. Okay? So that's how domain and range could be different if I had told you, if I had given you a different scenario where it gets caught at 6, right? Sorry? The range? This one? Is that wrong? You're saying no, because here it hits the ground. The question says assume hitting the ground. Yeah. The reason why I'm giving you so much info, guys, I'm going to give you some work time. Today I'm going to do a bit more, but I will give you some class time to wrap your head around this. Let's just finish this last bullet here, and then you can get started already. I. What does I ask us to do? Let's go check it out. It's important that you read this carefully. Write another equation that would model the path of a ball with a lower maximum height. A lower maximum height. So basically what I want you to do is like the OG, right, is this one. where is it again? Oh, 35t plus 4. Sorry, you can't see that down here. The OG, the original formula, looks like this. If I ask you, how could you rewrite this one to model the path of a ball that's lower, that doesn't fly as high?
Use a lower C value?
That's what I would do. Lower C value. Yes. The truth is, if you are clever, you can change any one of these three. Any one of these three, and you could possibly come up with one, and I'll show you how that works. Okay? Would something that says plus 3.99999 work? Yeah, that would answer the question as well. Okay? Decrease C. Right? That's what I did. And then voila, you got it. And if you want to see, am I doing this right? You grab your calculator. I don't know how to copy paste. A student once showed me how to do that, but you can't teach an old dog new tricks. You cannot. Anyways, I hope that I can still learn new tricks. But if you hit graph on this one, the red one is just slightly lower, right? I could actually change that to +1 to make it a bit more obvious, right? It's a little lower than before. So keep that in mind. That's how you double check to make sure that what you're changing is actually fulfilling the requirement. Okay, I'm going to ask you to do page, I would like to ask you to do 38 to 39. 2 questions, 2 graphs, right? All of that, I want you to practice. They're not as long as this one, okay? And I'll post the answer key. Thank you, guys.